Okay, in this lesson, we're going to talk about finding the volume of cones. And it's going to be a very familiar or very similar to finding the volume of cylinders, but with a tiny bit difference. And so here we have what our formula chart looks like. And so I really want you to pay attention to it. Remember these area formulas. These are the formulas that we need to be using for our capital B. Anytime we see a capital B, which stands for the area of our base, we need to be using those formulas. Also down at the bottom, we have, or down lower, we have our volume formulas, okay? So we need to make sure that we're looking at our volume formulas. So one of the first questions says, what does the capital B represent? And we said, we've already talked about that a capital B stands for the area of the cone's base. The area of the base, a capital B. Well, it says what shape is the base of a cone? Okay, so here's a bunch of cones over here. And so what do you think the bases are? What would we set that on? We would set it, hopefully you're noticing, on a circle, right? The shape of a cone's base is a circle, which is just like a cylinder, except for notice we only have one circular base on a cone. Okay? What is the formula for that base shape's area? Okay, so we talked about, here are our formulas. Here is our circle. Okay, these are for cones. We also know that it's for cylinders, so I'm going to go ahead and write that down. And so when we see a capital B, we need to look this up. Our formula is pi r squared. The area is equal to pi r squared, which equals your capital B, right? Oops, you can't see that. So it says substitute your answer for number 3, the capital B, into the star chart equation for the volume of a cone. Okay, so let's go up here. We see volume of a cone is 1/3 base area times height. So it's going to be 1/3. Our capital B, we said, was a circle. It's pi r squared, so I'm going to put pi r squared. And then remember, h stands for the height of the cone. Okay, and so I'm going to come back down here to the bottom, and I'm going to write down that same area, same formula, 1/3 pi r squared h. That's what we're going to have to use every single time we calculate the volume of a cone. Okay, so let's go over here, and I'm going to do one example with you. One example with you. And I want to do number 3 with you. Okay? So I want to remind you that our formula is 1/3 pi r squared h. We're going to write the formula every single time. And now we're going to fill in our numbers. We're looking for the volume. 1/3 is always part of the formula. Pi is always part of the formula. Okay, so now we need our radius. Notice, here's our circle base. We are not given the radius, we're given the diameter. And we learned the other day that to find the radius, we have to divide the diameter by 2 to get the radius. So our radius, 15 divided by 2, is 7.5, 7.5. So I'm going to say 7.5 squared, and then times the height. The height is always from the tip to the center. So notice here that it's 10. So times 10. So that's how you should fill in your formula. Okay, so now really important, We can do parts of this formula and calculate it, but you can also put it in all at once, and I really want us to practice doing that. Okay, so I'm going to add a calculator page. I'm going to do Control Divide to put in my fraction of 1/3. I'm going to use my arrow to arrow out. I'm going to use the pi button. And then I need to do times 7.5 squared, and then times 10. And I want you to see how it looks on my calculator is exactly how it looks on my paper. So you really need to double check yourself. It wouldn't hurt sometimes to put it in twice and make sure you're getting the same answer, because remember, a calculator is only as smart as the people that are putting in the numbers. And when I hit enter, I get 589.049. The directions told us to round to the nearest tenth. So my volume for this, the tenths place, it would round to just 0.0. So I'm just going to say 589. It was in inches, and remember it's inches cubed when we talk about volume. Okay? Now, the rest of the cones is on you. See if you can work through and calculate the volume of each cone.